Hello, for this video we'll do more graphing examples. This time it's going to be a little bit more challenging because we have limits involved. For our first example, we have a critical point at x equals 5 and the f prime is negative when x is less than 5 and x prime is positive when x is greater than 5. This means that the function is decreasing to the left of 5 and increasing to the right of 5. For the second derivative test, we have two inflection points and these are located at x equals 2 and x equals 8. We can also know that it is concave down at these two intervals and concave up at this interval. Now we have these two limits, and if you notice that if x approaches either positive or negative infinity, the function value approaches 3. This means that 3 is our horizontal asymptote. Let's start to graph our first interval, that is x less than 2. That is, we have a decreasing function and a concave down. Let's also remember that it approaches 3 as x approaches negative infinity. Next, we have the interval x greater than 2 but less than 8, and we know that at x equals 5, it has a local minimum based on the first derivative test. We also know that it's concave up according to the second derivative test, and it's going to look something like this. Finally, we have the last interval, that is x greater than 8. It is an increasing function and a concave down. And we also need to take note that as x approaches positive infinity, it approaches 3. So it also has a horizontal asymptote at 3. And that's it for the first example. Moving on to the next example, our critical points are found at 0 and 4. It is also given that f prime of x is equal to 1 if x is less than negative 1. That means the slopes of the tangent line when x is less than negative 1 is just 1, and that means it's just a linear function for that specific interval and that specific interval alone. From the given, we know that the function is increasing when x is greater than 0 and less than 2, and it's also decreasing when x is less than 0 but greater than 1 or greater than 2. We'll go back to these limits later on. For the second derivative test, we have a concave up for these intervals and concave down when x is greater than 4. Let's try to graph some points. And for our first interval, that is x is less than negative 1, we know that it is increasing because f prime of x is 1, which is positive. This means that the slope of the tangent line is 1, and it's just a linear function increasing from left to right. Our next interval is from negative 1 to 2, and we know that it has a local minimum at x equals 0. For the first limit, the slope of the tangent line approaches positive infinity from the left of 2. That means it approaches a vertical tangent line at 2. Next, we have the interval from 2 to 4, and that is a concave up, but it is decreasing. So it's gonna look something like this. And from the other limit equation, it tells us that it also approaches a vertical tangent line at x equals 2. Lastly, we have the interval x greater than 4, and it is a concave down and a decreasing function. So it's gonna look like this. And our overall function will look something like this. That's it for this video. Thank you for watching. Bye!